Alright, so we're going to talk about drilling. So these are bits which go into a brace. So there are 13 bits in a set. They range from 4/16 of an inch up to 16/16 of an inch, so 1/4 inch to 1 inch. You can get bits like this which are adjustable, where you can change the size of the hole. These are not typically with a standard bit set. So I've got a number 15 bit in here, which is 15/16 of an inch. And so the bit has 3 parts at the end that make it a very useful tool for boring holes. So this is an Irwin style bit, which means it has one flute that goes up through the side, and that is so that the wood chips will, as you're drilling down in the hole, the wood chips will follow the fluting and come up out of the hole so it doesn't clog. There's also a Jennings style which has 2 flutes, but the distinguishing characteristics of a bit has a lead screw. So this is a threaded screw that's tapered, and it will pull itself down into the wood as it cuts. So while you're using downward force on this handle at the top, the screw is helping pull it into the wood and cut. It also has these cutters on the side which determine the diameter of the cut. So when you sharpen these, you always sharpen from the inside so that you don't change the outer diameter, but these spurs will make a smooth outer circle as you cut. And then it also has these cutters here on the edge to give you a flat surface. So this is considered an 8-inch brace because there's a 4-inch diameter throw. So this ends up being 4-inch radius. It's an 8-inch diameter. So you can get these in a 10-inch. I don't think I've seen anything bigger than 10, but they probably make them. Now this is a ratcheting style, so you can tell right now that it's locked, so it's not going to move if it gets stuck. But by turning it this way, it ratchets in a way similar to a socket that's going to loosen a bolt. So there are bits that you can get in here for a screwdriver. You can get screwdriver ends for these types of bits, but the ratcheting is useful. For instance, if you're in the corner and you're trying to drill down, you can do this if you've only got 90 degrees to move, and that way you can still drill close to the corner where you can't get it around the entire way. So to drill this, it's usually easier to do it on a lower surface, but you'll put the hand up here, and if you have a square similar to this, you can set it up here to tell you whether you're going vertically in this direction, and then you can rotate it and to make sure that you know that you're going vertically in both directions. So that's a way to get started. And then it's putting pressure on here and turning, and as that lead screw starts biting into the wood, it pulls it down, and now the spurs are cutting the outer edge, and then those cutters on the bottom surface are leaving a smooth hole. So if I back this out, what you end up with is a smooth hole, 15/16 of an inch in diameter, and we're starting to cut through down. This is with a 3/8 inch piece of cherry, so it's not very thick, and it won't take very long. But you always want to do this when you're trying to bore a hole with some type of backing wood. This is a piece of basswood about 1 inch thick, because that lead screw, by the time you get to cut the bottom of the hole, the lead screw will poke through and start cutting into the whatever's below it. So you don't do this just on a workbench. But as we're cutting this through, what you want to look for is a change in color. And I can feel that it's gotten a little, and you end up with that cherry plug here on the bottom. The other reason why you do this is because as it's cutting through, it will splinter the wood on the other side if you don't have something backing it. So if you have to drill, let's say you have to drill into the side of the bench like this, if you're going through, you would drill from both sides. So you would You would go through until the lead screw pokes through the opposite side of the wood, and then you would turn around and put the lead screw in that hole and drill from the opposite side so that those spurs leave a clean cut, and that way you get a clean cut on both sides. This is useful for large holes. Depending on how big the hole is, the bigger the hole, the more torque you need, and the more difficult it is to work it. So if you're cutting a hole that's 1.5 inches in diameter, it can be a workout. So that is the brace and the bits. Now if you're going with something smaller, a smaller hole, actually same size hole, with power drill, you would use something like this. This is called a Forstner bit. So it has similar features to the brace and bit. It has a spur here in the middle that's not threaded, but that will help you locate the center of your hole and keep the bit going in the right place. It does have spurs here on the outside edge to give you that clean cut, and it also has this cutting surface in the middle that will give you a smooth bottom to the hole. So if you want to make a cut for tea light candles, you would use a 1 3/8 Forstner bit because that's the right diameter for the tea light candles, and then you would just bore down as deep as you need to get that diameter. 1 5/8 is a common one for small clock faces, but that's a good one if you want to put a larger hole. And for something like this, because of the round shank, it's just perfectly round. It's not like on a bit like this. It's tapered and four-sided so that it fits into the chuck, into the jaws there. This just clamps into a standard drill chuck, so a 1/2 inch drill chuck will work for this. But if you're going to drill smaller holes, you would use something like this. This is a hand drill or an egg beater drill. So this just has gears, so that as you turn this rotates around. So to loosen it up, you would just grab the gear like that to prevent it from spinning, and then rotate that and pull the bit out. So this is a brad point bit, which is similar to the Forstner. It's got a spur in the middle, and then it's got flutes, 2 flutes that come up to points. That spur in the middle keeps it locked in position so that it's not going to wander as you cut. So this is typically used for bits that are 1/4 inch or less, because you're not going to get nearly as much torque as you would. So you can hold it here or hold it here, whatever's comfortable, but then you're just rotating this around and putting downward pressure. And depending on if you've got it at a lower height or you're taller, you can put more pressure on with your hand or your chest and just sort of balance it. And I can feel that this has gone through the cherry, and I can tell it's gone into that basswood, which is a lighter color. But this is a quick way if you don't have a battery, or you don't have something mechanic or electrical powered. This is usually pretty quick. So you don't do this through deep wood. Use it for thinner pieces, smaller bits, but it's very useful to have with you just in case the battery dies. We also have files and rasps. So these are, this is a rasp, and a rasp is, these are handmade, so they have a random stitching pattern. That's what these are called, are stitches. And it's made by driving a sharp, hardened metal spike and tapping it with a hammer to raise these points up. So this is very rough. It's like a cat's tongue. And it takes wood off very quickly, but it does it because it's a random pattern. Machine rasps or machine-made rasps tend to, if you're going in a certain direction, they will create grooves because you'll see that the patterns follow an angle. And if you happen to be cutting at that angle, you will get that uniform groove in there and it will stop cutting. So for this, it's really just a matter of, you can put one hand on one end and the other on the handle, and it takes material off very quickly. So if you're trying to make a curved surface, this one happens to be flat on both sides. It has two different grain sizes, so it's a coarse and a fine. They do make them in rounded shapes. So this is a file similar to a rasp, but it's a finer cut. And this is a bastard cut file, so it's got the curve on one side and it's got the flat on the other. And if you need to, it's the same principle. You're just pushing and dragging it across, so it's pushing at the same time you're moving laterally. So you end up getting a little bit finer cut, and if you need to do a concave surface, this is going to leave them marks on the wood that are going to have to be cleaned up with a scraper or sandpaper. But if you've ever tried to create a curved surface on wood using a random orbit sander or power sander, it can be very easy to make a mistake. This gives you a little bit more control, but this is good for especially for inside curves. If you need to make a curve, like on a cutting board, somebody cuts a concave curve in there, you can use the rasp to help clean that up. Once that gets done, the next step would be take a dowel rod and wrap sandpaper around it and just slide that in the curve to clean up any of the marks that are left by the machine surface of the rasp or the file. But that'll clean those up pretty quickly.
All right, thanks,
Did you want to do chisels? I can do those.
Yeah.
Very quickly. I've got everything. All right, so chisels, we talked a little bit about planes. A chisel is just a flat piece of steel. In this case, it's got a little bit of a slope to it because it has this, it doesn't have a tang to it. It has a hollow. So for a chisel, you'll notice it has this bevel. So it's flat on the bottom, flat on the top until you get to the very end, and then it angles down. So typically for a chisel or a plane, that bevel is about 30 degrees. For a kitchen knife, the angle that you would have, the cutting edge of the knife is going to be narrower, maybe 20 degrees. But 30 degrees is a nice compromise between a thinner angle, which will slice more cleanly, and a thicker angle, which is more durable. If you tried to use a kitchen knife to cut wood, it would damage it very quickly because it just wouldn't stand up to the abuse. So the more metal that's behind this, the easier it's going to be to maintain that edge, and you don't have to sharpen as often. So this is shiny right behind the surface, so right up to this edge, mirror finish, because you want that to be highly polished. That will give you a more durable edge. And then right along the edge on the bevel is also shiny, because where those two planes meet, you want to have no radius of curvature. You want them to meet perfectly, and that's going to be sharp. So this is what's known, similar to this, is called a firmer chisel, because these are flat on the sides. There's no side bevel. This one's a 2-inch wide. This is about 1.25 inches. But these are very old, but they're durable, and it does not. You can see here, this is what happens with tear out, because I'm going in the wrong direction. But if I'm not going in the wrong direction, you can take very fine cuts with these, because they're very sharp. Sharp is important. The other types of chisels are the bevel edge chisels, which are so called because on the edge of the sides they have it's beveled down to almost nothing. Now this This is the difference between a $5 chisel and a $50 chisel. This is an Irwin, very good chisel. Doesn't take long to get it sharp, and it's a good workhorse. This is a Lee Nielsen. The difference is in the balance in the steel and the quality of the manufacturing. So on the side here, there's almost there's a very tiny, maybe a 64th of an inch wide piece, which means that this can get into a dovetail and chop it very cleanly. Here, it's flat along the side. Even though it has this bevel on the side, there is a flat piece, which means you couldn't get in and use this for dovetailing unless you ground that down to almost nothing. So there would still be a lot of work to be done on this. Also, this is a plastic handle. This one's wooden. So this is hornbeam, I think. The balance is very different. This one tends to wobble around in your hands. This one is very stable. So when you're chopping, so if you're chopping, you want to hold the chisel by the metal. And when you're doing that, the wood is lighter than the plastic. It's less dense. So you get more stability. It wants to stay upward. Whereas if I were to do this one, it's a little more unwieldy. And it's a little, you can still use it. It's just not quite as good. You can make a $5 chisel super sharp, every bit as sharp as this. This one is O2 tool steel. I have no idea what this steel is, but I know the manufacturer for this. So the steel is good quality. I didn't have to do very much work to get this flat on the back and on the bevel, and it stays sharp for longer. So it's a higher quality chisel. So if you're using it a lot, this is a good one. I've done a lot of work with this kind of chisel as well. The only thing that you have to be careful of is this is a 19mm chisel. It also says 3/4, but 3/4 is not 19mm. So if you're working with precision tools, it's not going to be the same, whereas this one is 3/4 of an inch. So depending on which side of the ocean you're on, and you're using metric or English, always be aware of that. Especially if you're going to use something like a 1/4 inch chisel to draw out a mortise. If you're using a 1/4 inch chisel versus a 6mm chisel, you're going to have to do extra work.
Strangely, the same thing is